Hey there, welcome to our next video on vectors. In this video, we're going to talk about unit vectors, what they are and what they mean. So, first, remind you what a vector is. A vector is a magnitude and a direction. So, what is a unit vector? A unit vector refers to the word unit. So we measure things in units, like Fahrenheit. Like 62 degrees Fahrenheit is a magnitude, and it's a magnitude of 62. And we measure that in degrees of 1 Fahrenheit versus 62 degrees Fahrenheit. And we can do it with anything else like inches. Inch itself is the unit, a single inch. And think of anything else. Like you can have it be whatever you want to be, any way to measure. It can be temperature, it can be size, be density, whatever that is a unit. Like meter square, just anything. Think of anything. So a unit vector is the direction. So we've talked about magnitude before, and that you can quantify magnitude as a single number. Like 62 degrees Fahrenheit, 32 meters, 42 inches. That's a magnitude. So how do you quantify the direction by itself and remove the magnitude from your vector and describe what your vector is? Well, think about it like this. You have a vector. This is vector v. Say hi, vector. Anyways, vector v has a magnitude of, I don't know, like 5. And so that means it goes 5 units in that direction. It could be, let's say, 5 meters to keep it simple in your head. 5 meters. So 1, 2, 3, 5. 1, 2, 3, 4, 5. And then it stops right there. So we have a vector that is 5 meters long. So a unit vector would be taking a single one of these, a single unit, a single meter out of our vector. And if it's temperature, if it's anything else, you just take one. So how do you calculate that? Well, it's literally this. How many of these are there? 5. So we just divide the magnitude by 5. Simple as that. And once you have that, what you're going to have is you're going to have a tiny vector with a length of 1. However, your direction is going to be exactly the same. Not too complicated. And that's the importance of the unit vectors. Being able to say my vector goes in that direction, and then you can put it onto anything else. So let's actually calculate this. Let's say that it has a magnitude of 5, but actually I need to calculate this so I can make a good example. Okay, I've decided not to calculate it. We're just going to say it's not a length of 5. Let's pretend that it goes... The vector itself is 5 and 7. So the vector it looks like this. This is the vector itself. So to figure out the unit vector, we have to figure out its magnitude. And I don't think we've talked about this before, but we're going to talk about it right now. How do you find the magnitude of your vector? Actually, I did mention it once. But the way you do it is just Pythagorean theorem. It's just finding the distance between 2 points, as if the first point here was 0, 0. So you can do it like this. Remember, Pythagorean's theorem is a squared plus b squared equals c squared. And you remember that a vector has a starting point and it goes the side and it goes up. What you do, 5, 7, and you're just finding the hypotenuse, or c. The hypotenuse is a, b, c. Hypotenuse is c. So it's just, with this one, 5 squared plus 7 squared, and the root of that is equal to c, which is the length of our vector and the magnitude. That's the magnitude explained simply. So 5 squared plus 7 squared, 25, 49, 1373. So what's the magnitude of our vector? Magnitude of our vector is the root of 73. Simple enough. That's not a happy number or a simple number, but that's the number we get. So let's bring it back over here to our vector. So I'm going to take off these. And so our vector is divided into root 73 pieces, whatever number that is. Probably somewhere around like 8 point something, like 8.5, I guess. And so root 73, the way you calculate it is, remember when this used to be magnitude 5 and you just divide it by 5? Well, if you want a vector right here, it has the x values and the y values, so you just have to divide the x values by your vector and your y values by not your vector, by your magnitude. Because each of these is a magnitude in its own respect. Each, like if you're going 5 on the x-axis, that's a magnitude of 5 on the x-axis. You're going 7 on the y-axis, that's a magnitude of 7 on the x-axis. So you just have to divide by your magnitude of the actual vector, and you're going to get a unit vector. So our unit vector actually looks like this. The unit vector for vector v is equal to 5 root 73 over 73. I just did the conjugate to make it look prettier, just so the root isn't on the bottom, comma, 7 root 73 over 73. And it looks like that because it's a vector. When it's a vector, remember you have to put these things on the end. And this is what it looks like. I can't take questions because you're not actually real, but this is how a unit vector works. It's just what it is. Sorry, I wanted to finish that sentence, but I didn't have anything good to finish it with. This is going to be a unit vector, or no, a vector with a length or magnitude of 1. So unit vector, magnitude 1, but keep in mind the direction is going to be the same. So if we drew a triangle like this, and it was 5 root 73 over 73 on the x-axis, which is what our x-coordinate is, and our height was 773 over 73. This angle right here, angle theta, is going to be exactly the same as the vector here. So this angle theta is going to be that angle theta. And that's why the unit vector is important. It's a way to get the vector, but simplified down to where it's just, essentially you can think about it in terms of the angle. It's going to be important later on. Anyways, hope that explains the unit vector pretty simply. I don't have any examples because I don't understand it that fantastically, but we're going to get there.